I welcome you in our social science class for 6th grade. We shall begin with our geography book. Let's start with chapter number 3, Motion of the Earth. I assure you that this video will be very interesting and informative to you and brings smile on your faces. Students, these two pictures presented here are an introduction to your book and study material it consists. The title of chapter clearly reveals that our earth has some motions. What are these and what effect of these motions of the earth in our life? We also study the earth's position in the solar system with respect to the sun and other planets. Students, before going to learn the motions of the earth, one should have the basic knowledge of solar system and important latitudes and longitudes. Probably you studied in your first chapter the earth in solar system and the second one globe, latitudes and longitudes. Let's explore little more about these before going to start our chapter motions of the earth. Students, this is our solar system. The solar system, the sun, 8 planets, satellites and some other celestial bodies known as asteroids. Solar system, we often call it a solar family with the sun as its head. The sun is in the center of the solar system. It is huge and made up of extremely hot gases. It provides the pulling force that binds the solar system. The sun is the ultimate source of heat and light for the solar system. But that tremendous heat is not felt so much by us because despite being our nearest star, its sun is about 150 million kilometers away from the earth. Students, you can easily understand this concept in your own families and village or city. There may be more than 100 families in your village or city and each one has its family head to maintain the discipline in family. Mostly, the head of the families is the senior most member like grandfather or sometimes father. This head has key position in the family and rest of the members totally depends upon it for their need. Same in solar system. All the other members totally depends upon the sun for their basic need, that is heat and energy, and they revolves around it. If you watch the sky at the time of dark night, you will notice that millions of billion stars in the universe and each has its family like your village or city. Dear students, one more important thing I want to clear here, the star of our galaxy. Let's know little more about its family, especially planets the earth. Planets. There are 8 planets in our solar system. In order of their distance from the sun, they are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. The most important and unique planet, Earth. The Earth is the 3rd nearest planet to the sun. In size, it is the 5th largest planet. It is slightly flattened at the poles. That is why its shape is described as geode. Geode means an Earth-like shape. Conditions favorable to sport life are probably found only on the Earth. The Earth is neither too hot nor too cold. It has water and air, which are very stable. The air has life-supporting gases like oxygen. Because of these reasons, the Earth is a unique planet in our solar system. From the outer space, the Earth appears blue because its two-thirds surface is covered by water. It is therefore called a blue planet. Now see the picture carefully. In this picture, you can revise your knowledge of important latitudes of the Earth. Equator at 0 degree, Tropic of Cancer at 23.5 degree north, Tropic of Capricorn 23.5 degrees south, Arctic Circle 66.5 degree north, Antarctic Circle 66.5 degrees south, 90 degree North Pole and South Pole. Students, now we can easily understand our topic motion of the Earth. As we discussed earlier that each member of the solar system is revolving around the Sun, Earth is not an exemption of it. Rather, it also rotating on its axis too. Or you can say that it has two types of motions. In this picture, you can see the motions of the Earth. Revolution. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. Let's study the rotation of the Earth. The Earth rotates around an imaginary line that passes through its north and south pole. This imaginary line is its axis of rotation. Earth rotates from west to east. It takes 24 hours to complete one rotation. Now study these pictures carefully. The Earth's axis of rotation is tilted 66.5 degree with respect to its orbital plane around the Sun, and its axis of rotation is inclined 23.5 degree from the perpendicular with respect to this plane. The tilt of the Earth affects the angle between the sun beam and the normal over a surface. The axis of the Earth, which is an imaginary line, makes an angle of 66.5 degree. What is orbital plane? The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis as you see in the picture. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth day. This is the daily motion of the Earth. Students, what would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions. Do you know? Earlier it was believed that Earth is flat and stationary on its axis. The ancient Indian astronomer Aryabhatta had stated that the Earth is round and rotates on its own axis. Now the second motion of the Earth, revolution. The second motion of the Earth around the Sun in its orbit is called revolution. Students, it takes 365 1/4 days to revolve around the Sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. 6 hours saved every year are added to make one day, 24 hours, over a span of 4 years. This surplus day is added to the month of February. Thus, every fourth year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will the next leap year be. In this picture, you can see that Earth is going around the Sun in an elliptical orbit. Do you know how to draw an ellipse? Take a pencil, 2 pens and a loop of thread. Now fix these pins on a paper as shown. Put the loop on the paper and closing these 2 pins inside the loop. Now hold the pencil and draw the line, keeping the thread tight and moving the pencil along it. The figure represents an ellipse. Notice that throughout its orbit, the Earth is inclined in the same direction, that is anti-clock. Students, a year is usually divided into summer, winter, spring and autumn seasons. Seasons change due to the change in the position of the Earth around the Sun. In this picture, you can see the Earth has its top tilted away from the Sun. This means the northern hemisphere, the top half, receives less direct solar radiations than the southern hemisphere, the bottom half. That variance causes the northern hemisphere to experience winter while the southern hemisphere experiences summer. If Earth didn't revolve, this situation would never change and northern hemisphere would experience constant winter. Fortunately, Earth is not static and does revolve. When the northern and southern hemispheres are experiencing equal amount of direct solar radiation, this translates to spring and fall in the respective hemispheres. Depending on the weather, we are moving towards summer or winter. Now look at this picture. You will see that on 21st June, the northern hemisphere is tilted towards the Sun. The rays of the Sun fall directly on the Tropic of Cancer. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the Sun are slanting. The North Pole is inclined towards the Sun and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the northern hemisphere is getting light from the Sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on 21st June. At this time in the southern hemisphere, all these conditions are reversed. It is winter season there. The nights are longer than the days. This position of the Earth is called the summer solstice. On 22nd December, the Tropic of Capricorn receives direct rays of the Sun as the South Pole tilts towards it. As the Sun's rays fall vertically at the Tropic of Capricorn, 23.5 degrees south, a large portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the Earth is called the winter solstice. Do you know that Christmas is celebrated in Australia in the summer season? On 21st March and September 23rd, direct rays of the sun fall on the equator. At this position, neither of the pole is tilted towards the sun. So, the whole earth experiences equal days and equal nights. This is called an equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus, you find that there are days and nights and changes in the seasons because of the rotation and revolution of the earth respectively. Students, let's do exercise of this chapter to check our knowledge, what we have learned so far. Answer the following question briefly. Question number 1. What is the angle of inclination of the Earth's axis with its orbital plane? Student, answer is 66.5 degree. Question number 2. Define rotation. Answer is the daily motion of the earth on its axis is known as rotation. Question number 3. Define revolution. The answer is motion of the earth around the sun in its orbit is called revolution. Question number 3. What is a leap year? Answer is a year with 366 days is called a leap year. Tick the correct answers. Question number 1. The movement of the earth around the sun is known as option A, rotation, B, revolution, C, inclination. The right answer is option B, revolution. Question number 2. Direct rays of the sun fall on the equator on option A, 21st March, B, 21st June, C, 22nd December. The right option is A, 21st March. It is known as equinox. Question number 3. Christmas is celebrated in summer in option A, Japan, B, India, C, Australia. The right answer is option C, Australia, as it lies in southern hemisphere. When it is winter in northern hemisphere, then summer in southern hemisphere. Question number 4. Cycle of the season is caused due to option A, rotation, B, revolution, C, gravitation. The right answer is option B, revolution. Now fill in the blanks. A. A leap year has dash number of days. Answer is 366. B. The daily motion of the earth is dash. Students, we know that the daily motion of the earth is rotation. Answer is rotation. C. The earth travels around the sun in dash orbit. Answer is a fixed orbit. D. The sun's rays fall vertically on the Tropic of dash on 21st June. Students, we know that 21st June, summer solstice, and on that day, Tropic of Cancer faces sun rays vertically. So, answer is Tropic of Cancer. E. Days are shorter during dash season in respect to northern hemisphere. The answer is winter. We have studied about it, that in winter northern hemisphere has long night. Now student, you have to do something. on your own. Number 1. Make a drawing to show the inclination of the earth. Number 2. Record the timings of sunrise and sunset at your place, taking help from your local newspaper on the 21st of each month, and answer the following. A. In which month are the days the shortest? B. In which months are the days and nights nearly equal? Dear students, in this chapter we have studied the solar system, motions of earth, their effect on day and night, and seasons. You have learned the reasons why the opposite conditions of seasons in both hemispheres are found on the earth. Now you are able to explain easily what would happen if the earth stopped rotation and revolution. So I will take your leave now. Thanks for watching this video carefully from the beginning to end. Stay healthy.